we're going. All right, so it is November 30th. And we're still looking at section 4.1. But today we're going to talk about these things called differential equations. So this will just sort of be an introduction to these things called differential equations. Intro to differential equations. And I think the first thing we need to know is what a differential equation is. A differential equation is just any equation that includes a derivative. A differential equation is any equation that includes a derivative. So an example of a not super easy differential equation is something like 2x minus 3 dy dx equals 6y. That's an example of a differential equation. When you solve like a regular equation, your goal is to figure out what x equals. X is 4, x is 3 halves, x is whatever. Our goal here is not necessarily to find x, because there's x's and y's here, is to find a function, y of x, that would make the equation true. Our goal is to find a function, y of x, that makes the equation true. Which means in this problem, I need to find some function. So if you do 2 times x minus 3 times the derivative of the function, you get 6 times the function itself, which is a lot to think about. And in case you're wondering, the answer is y equals c e to the negative 2x plus x over 3 minus 1/6, right? Good. Yeah, okay. That's not really what we're going for. But the goal, again, is to figure out what exactly the function will be that will make everything work. Again, 2 times x minus 3 times the derivative of some function should equal 6 times our function that we found. Let me show you a much easier differential equation. We are going to look at solving the differential equation dy dx equals x cubed minus 4x. We're going to go solve this differential equation. Which means I need to find a function whose derivative is, well, just x cubed minus 4x. Let me actually write down that question. I am looking to figure out what function, y of x, has a derivative of x cubed minus 4x. Does this question sound like something you know how to do? Like, what sorts of problems involve answering the question, what has this as its derivative? We're in section 4.1. We did more 4.1 stuff yesterday. What's this about? Hannah, what's this about? Isn't this just like asking, what's the integral of x cubed minus 4x? Because integrals ask the question, what has this as its derivative? Here's how we're going to solve this. The function y is just going to be whatever the integral of x cubed minus 4x, I'll stick a dx at the end, will end up being. You know how to integrate that. Go integrate that. And Richie, what is the answer?
X to the 4th over 4.
Yeah, so minus 4x squared over 2, so minus 2x squared. Well, almost. Plus a constant. We've just solved our first differential equation. There is one difference between this and yesterday. The only difference is now our answers are functions. So they need to be y of x equals, or y equals. That's it. That's the only difference. Easy enough? I don't really feel like we have to do many more of these. I'm going to give you a derivative. You tell me the original. That just means find the integral. Only extra piece is I need them to be y equals things. When we deal with these differential equations, there are two different types of solutions we're going to get. The first type of solution we could get to a differential equation is what we call our general solution. This is a solution that includes a constant at the end, includes a plus c. Those are not terribly interesting because that is exactly the same thing we did yesterday. That's no different than yesterday. What we're going to spend the rest of today on is dealing with finding what we call particular solutions to differential equations. In a particular solution, given additional information, we will find a specific value of c. It's not going to be plus c anymore. It's going to be plus 5 or minus 2 or some number at the end. So again, given additional information, we are going to find a specific c. Find a specific value of c. Move this up. Let me start a new page over here. So whoops. Oh, there we go. So we're going to look at solving the differential equation. Y prime of x equals x squared minus 5x plus 4. I'm telling you that some function has a derivative of x squared minus 5x plus 4. And I'm also going to tell you that y of 0 equals 2. This piece at the end is called our initial condition. And that's the extra piece of information we're going to use to find our specific value of c. But I'm not going to do anything with that yet. I'm telling you the derivative is that thing. Well, doesn't that mean that the original function y of x just has to be the integral of that thing? Maybe? Integrate. Get a plus c and stop. Harmon, do you have your antiderivative? What do you have? Good. Any issues with the antiderivative? What we just found is our general solution to that differential equation. But now, I need to do a little bit of work to figure out what exactly my c value is. How am I going to do this? Quasi.
Since you already know that 0 is 2,
So go back to what you were saying before, because this is kind of a special case in this problem. But in general, what would you do, Quasi?
in general, I would just plug in 0 into my equation.
For x,
Yeah.
and set it equal to?
Um,
To 2. I'm telling you, you plug in 0, it's going to equal 2. So let's go and just plug that thing in. We are going to get, okay, so I know that y of 0 is going to equal 1/3 times 0 cubed minus 5 times 0 squared over 2 plus 4 times 0 plus c, and we know that it equals 2 because I told you it equals 2. There's a whole lot of 0 stuff going on over here. That stuff is all 0. Our constant is 2. Our solution, our particular solution to the differential equation, is y of x equals x cubed over 3 minus 5x squared over 2 plus 4x plus 2. This is our particular solution. Our goal was to find a function whose derivative is x squared minus 5x plus 4. Well, does the plus 2 affect that? No, if it was plus 5, plus 2, minus 3, the derivative would still be that thing. But because I gave you that extra piece of information, this function, yes, has that as its derivative, but also has the property where if you plug in 0, you get 2. Do you see how this works? No, the c value will not always be just the number that we see here. We often will actually have to plug in and deal with that stuff. But in this case, it was nice and easy, because this was the first example. Let's take a look at a few more. Let's deal with solving the differential equation. Y prime of x equals, I think we need to do some trig. Let's do the cosecant of x times the cotangent of x. And I'm going to tell you that y at pi over 2 equals 3. And you know what? I don't think I need to explain anything about this one. Go solve it. Telling you the derivative, find the original. And when you're done, use that piece of information to find your constant. At the end of class, if we have a little bit of time, I'll get out index cards. We'll make a flashcard with the 6 trig integrals, because we'll definitely have to know those for our first quiz, and honestly, for the entire second half of the year. So I guess we'll get those written down somewhere. Kaylee, I know you're not done, but do you have the antiderivative part taken care of? Antiderivative of cosecant x, cotangent x? Minoj? Negative cosecant x. That's all we're going to do there. Well, almost. Negative cosecant x. Plus c. What has a derivative of cosecant x, cotangent x? Negative cosecant x. Plus the constant. Now go do the plugging in work. By the way, c is not just the number 3. I don't think it is. It is? I don't think so. Julia thinks it's 4. Okay, so here we go. 3 is going to equal the negative cosecant of pi over 2 plus the constant. I don't want to think about cosecants, I want to think about sines. What's the sine of pi over 2? 1. What's 1 over that? Still 1. You are going to get 3 equals negative 1 plus a constant. Julia said c was 4. C is 4. Right, yeah. Julia said it was 4. Julia's right. Y of x equals... Yes, because you made a sign mistake. Y of x equals the negative cosecant of x plus 4. And yes, obviously, when we do have quizzes on this, if there's trig, I'll have unit circles if you want them. Are you still not sold on? No, okay. Questions from anyone? Well, we need to look at a tougher differential equation. Let's take a look at, yeah, we do. We're going to take a look at the differential equation y double prime of x. Oh my gosh. Equals 3x squared minus 4x minus 2. I'm going to tell you that y prime of 1 equals 5. And I'm going to tell you that y of 2 equals negative 3. How is this different? You're given a second derivative. So before we go on, there is a little bit of language that I just want to introduce to you. That last problem, y prime of x equals cosecant x cotangent x, we would actually call that differential equation a first order differential equation because it only involves first derivatives. That is a first order differential equation. The problem I just gave you that has a second derivative, we're going to call this, ready for this? Second order differential equation. Not a difficult name. Oh my goodness. Second order differential equation. The goal is still the same thing, though. The goal is always, with these things, find the original function. Well, here's the deal. You can't do this right away. You cannot go from the second derivative to the original function directly. What am I talking about? What do we have to do? Raise your hand. Kaylee.
You have to find the first derivative.
Okay, we can go from the second derivative to the first derivative, and when we're done with that, we can go from the first derivative to the original. That's all we have to do here. So really, we're just going to do our integration, but we're going to do it twice. So, the first derivative is just going to equal the integral of 3x squared minus 4x minus 2 dx. Let's actually do this part together. Y prime of x is going to equal, okay, you're just going to tell me things. What's the integral of 3x squared? X cubed, 3x cubed over 3, so just x cubed. And what is the integral of minus 4x? Minus 2x squared. It's really minus 4x squared over 2, which becomes minus 2x squared. Integral of minus 2?
Minus 2x.
And are you done?
No.
Plus c. Okay. I'm going to pause at this part. I am not going to go on right now and find the original function. Before I do that, I want to figure out this value of c. How? Well, what though? Sanjana, there were two pieces.
Since 5 goes in the y prime of x and plug in
Yeah.
1 for x.
You're going to ignore that y of 2 equals negative 3 thing for now. You're going to use the information you were given about y prime. You're going to plug in 1 for x. You're going to set it equal to 5. And you're going to get your constant from your first derivative. There will then be a different constant in the original function. Go do it. Does 8 sound about right? Okay, so I have y prime of x equals x cubed minus 2x squared minus 2x plus 8. That's not my final solution, but that is the solution to my to what the first derivative will be. Well, I think you know how to find the original now. Go do it. It will be a little messier. That's okay. I would like you to try this without a calculator, because when we get to a quiz on this stuff, it'll be without a calculator, so we should be able to work with some fractions. Oh my gosh, you can do it. Go do things. Check to see if your antiderivative looks like mine. I think that's actually the easy part here. Fuzzy?
Never mind.
After a little bit of work, but I didn't feel like doing like really complicated fraction stuff, so I just kind of moved everything without a fraction to the other side and then did some common denominator things. I got negative 41/3. This is not your answer, though. What do I mean? What is the answer? Sabrina. The whole thing. Don't just find the c value. Actually give me a function for your answer. Your final answer here is going to be y equals x to the 4th over 4 minus 2x cubed over 3 minus x squared plus 8x minus 41/3. Yes, we might have to deal with some fractions every now and then. Any questions here? There is honestly only one more thing I want to take a look at today. We're going to go back and do something with particle motion, because we can never do enough particle motion. Particle motion. By the way, when we get to the AP exam in May, there are 6 free response questions on the AP exam. I can almost guarantee you one of those free response questions will involve particle motion, like the quiz you just got back with a few additional pieces we haven't yet taken care of. There's been a particle motion quiz every single year for the past at least 20 years, so I wouldn't imagine this year would be any different. Let me give you an example. A particle's acceleration is given by the function a of t equals t plus the sine of t. Its initial velocity is 0, and its initial position is 1. We want to find its position at time t equals, there's trig in here, so I'm going to make it t equals pi over 2. The acceleration is given by a of t equals t plus the sine of t. The initial velocity is 0, initial position is 1. We want to find the position at time pi over 2. On your quiz that you just got back, what did I give you in the beginning? What function did I give you? Position. I'm not telling you the position here. Instead, I'm telling you the acceleration. Well, here's the deal. On that quiz, I gave you position. We found the derivative, which gave us what? Velocity. What happened when you found the derivative of that? Acceleration. As we go down this list, we're finding derivatives. So how are we going to go up this list? Integrals. If you have acceleration, we can do an integral to get velocity. If you have velocity, you can do an integral to get position. Does that make some sense? You know what? Before I do this, let me kind of rewrite this problem just in symbols rather than like in words. I told you that the acceleration is t plus the sine of t. If the initial position is 0, like how can I write that in symbols? Manoj? Yep. Let's not do subscripts in here. Let's do like function notation things. Good. The velocity at time 0 is 0. And if we're using s for our position function, we can say s at time 1, nope, s at time 0 equals 1. A double prime, isn't that like a derivative? Actually, isn't that like a second derivative? Isn't it kind of like I'm telling you a second derivative? Telling you information about the first derivative, telling you information about the original. Isn't this exactly like what we just did? This is a second order differential equation. I would like you to take a moment and create your velocity function. You've got acceleration, integrate that. Get a constant, find the constant. Velocity is just the integral of acceleration. T squared over 2. Is it minus or plus cosine t? Just say it. Minus, yeah, because the integral of sine is negative cosine t, because the derivative of cosine is negative sine, so derivative here is negative sine. You should have this for your velocity. And you now need to take just a moment and figure out your c value. Does 1 sound about right?
Yep.
So the velocity should be 1/2 t squared minus the cosine of t plus 1. I think you know the next step. Go create your position function. And actually the last step of this problem, find the position at time pi over 2. Shouldn't that be easy once you have the position function? That's all you're going to do, create the position. Once you have it with the c value figured out, you're just going to plug in. Take a few moments, let's get that position function, and then we'll plug into it. So your antiderivative look like 1/6 t cubed minus sine t plus c. Find your c value. And when you're done, you're just going to plug pi over 2 in. It's going to be messy, but that's fine. Just leave it as an exact thing with pi's in the answer and stuff. I got a c value of 1. Pi cubed over 48 plus pi over 2, which looks terrible, but I don't think should have been too difficult to calculate. You're just plugging things in, cubing, and realize you can't do much more with that. Any questions or issues so far? What the AP exam tends to do, which actually you'll see in the homework, is not actually give you acceleration, but rather give you velocity and ask you to find position and acceleration. Why would they do that? Why would they give you velocity and ask you to find position and acceleration? Hannah? Absolutely. Can you find an integral to get your position? Can you find a derivative to get acceleration? And then, of course, once all that stuff is done, then they're going to ask you, is the thing moving left? Is it moving right? Is it speeding up, slowing down? Everything you just had on your last quiz. Shouldn't they be able to get as much as possible out of one problem? Otherwise, it's kind of like a wasted problem. One other quick thing that I want to show you. So, in physics, you guys talked about free fall motion and dropping something, throwing something. You had some formula for finding the height of something, right? I'm not entirely sure of the notation that Mr. Coakley or Mrs. Isfan might use, but is it something kind of like this? Have you worked with something like that? Okay, what do you do differently when you write this formula? A instead of G? Yes? No?
That's backwards. Yeah, that's backwards.
Maria, Nathan? Yes? It's okay, the order doesn't matter. You guys use A, though, instead of G?
Yeah.
Yeah, and the X hour just doesn't.
Okay, fine.
And
Probably zero.
So you're kind of given this formula and you have to figure things out. You want to see where the formula came from?
Yeah.
Just say yes. Okay. Here's where the formula came from. For free fall motion, or like dropping an object motion and stuff, what is your acceleration?
gravity.
It's due to gravity. It is a constant acceleration. I'm going to start from the acceleration function, which is just a constant a. I kind of don't like the fact that there's a's in two cases, but this is a function, this is a constant. Yes, you're okay? What's your initial velocity? No. What's your symbol in physics for the initial velocity? V sub 0. So I'm going to say that at time 0, what's your velocity? Well, whatever V sub 0 is. And I'm going to say, I guess you're not using S, I guess you're using X, it's the same thing. I'll say that the initial position is X sub 0. Okay? Really, I have a second order differential equation here. I've got the acceleration. I'm going to create my velocity function. This might be worth copying down, maybe. I'm going to integrate my acceleration, which is really just that constant A. I'm going to say my variable is t, so I'm integrating A dt. When you do that, is the integral of A dt A squared over 2 plus a constant? Yes, it is, because according to the differential, that's why it's important we have those differentials there, t is our variable, A is just a constant. So integrate A dt, you're going to get AT plus some constant. Okay, so far? I'm going to plug in 0 for t. I'm going to set it equal to V sub 0. I'm going to get A times 0 plus C. What's your constant? V0. My velocity function is AT plus V sub 0. Is this the formula you've used and seen in physics? It comes from just integrating the acceleration. Okay. Well, I think you know where to go from here. We're just going to integrate that velocity function, get a position, and then do our initial condition stuff, and hopefully we'll create the same formula you've been using. So x of t. Physics comes from calculus. Calculus was basically invented to create those physics rules. And all this stuff is based on the acceleration's a constant, so we can integrate it to get a position formula. So here we go. So here we go. T is our variable. If we integrate A, which is a constant, times t, what do you get? AT squared over 2. I'll rewrite that in a moment if we want. If we integrate V sub 0, which is a constant, V0t, constant times my variable. Anything missing? Plus constant, plus C. Here's my position function. If we plug 0 into this thing for our time, it should equal x sub 0. 0 plus 0 plus C, our constant x sub 0. And because you're not used to at squared over 2, I might as well write it as 1/2 at squared. It's the same thing. Plus b0t plus x0. This really just comes from calculus. And not even like super difficult calculus. It's just integrating. It's integrating a constant, getting a function with a t in there, constant at the end, integrate it again, you get something with the squared. That's where that formula comes from. Make sense? Go tell Mr. Coakley and Mrs. Isfan you understand where that formula comes from now. Okay, let me shut this off. There's one more thing we do need to take care of today.